everyone, my name is Terran Giarcalo and this is my report. Three-D graphics programming. Programming refers to the process of creating and manipulating three-dimensional 3D. Computer graphics in software application. Ang 3D ay may tatlong bahagi. Meron itong taas at lapad at lalim. Para magmukha itong dimensional 3D, makikita ng mga tao ng object na ito ay hindi flat. And this field is essential for developing video games, simulation, virtual reality. VR. Ginagamit ito sa app ng computer at dito mo malalaman at matutuklas ang 360 degrees. At ginagamit din ito sa paglalaro at kapag ito ginamit mo, para ka nasa loob ng isang games na nilalaro mo. At AR architecture. Ang AR naman ay ginagamit ito na parang digital 3-dimensional na bahagi ng isang unawa ng isang individual sa totoong mundo. Like, pag itinapat mo yung cellphone mo, may mga details na lalabas doon. At
a few moments later,
maaari mo makikita ang mga information.
Oh my God! Wow!
Geometric 3D graphics. At the core of 3D graphics programming is the representation of 3D objects and scenes through geometric data. These include defining vertices, points and edge line, and face polygons that make up 3D models. Sa 3D geometry naman, maaari tukuyin ang isang 3D dimensional na hugis bilog, solido at figura o hugis. At ito ay may haba at lapad at may taas. Hindi tulad ng sa 2D na may hugis na may taas at nakapareho lang o lalim. At sa mga tuwid, ang mga figure na ito ay lahat ng tatlong dimensional na figure ay sumasakop sa tatlong dimensional na sukat sa mga tuntunin ng volume.
a few moments later,
two-dimensional plane with respect to its distance from the reference axis. In three-dimensional space, we identify a point with respect to the distances from the three reference planes. Let's see what these reference planes are and how to locate a point in space. We take two planes perpendicular to each other. The intersection of these two perpendicular planes is a straight line. Let's take another plane perpendicular to both the existing planes. With the intersection of this plane with the two existing planes, we get three lines mutually perpendicular to each other. These lines are called axes and are named as X, Y, and Z. The point of their concurrence is called the origin. The origin is denoted by the letter O. By convention, we consider the XY plane as the horizontal plane. Distances are measured starting from the origin. Distances measured in one direction are taken as positive and in the opposite side as negative. For example, the distance measured from the origin along the x-axis along the direction shown is taken as positive. The distance measured from the origin in the opposite side is considered negative. To indicate this, we assign the symbol x dash. A similar convention is followed for calculating the distances along the y and z axes. The plane formed by the x and y axis is called the xy plane. Similarly, the plane formed by the y and z axis is called the yz plane, and the plane formed by the z and x axis is called the zx plane. The xy plane, yz plane and zx plane divide space into 8 octants. Here, XOYZ is an octant. This octant is enclosed by the XYZ axis. Similarly, the other octants are named according to the axes that enclose them. Any point in space is represented with the help of the distances that it measures with respect to the planes. These distances are called the coordinates of the point. Suppose we have a point P in space. The coordinates of this point are x, y, z. Each coordinate individually indicates the shortest distance of the point from the corresponding plane. For example, the coordinate x determines the shortest distance of the point from the yz plane. Similarly, the y coordinate represents the distance of the point from the zx plane, and z represents the distance of the point from the xy plane. The coordinates of the origin are 0, 0, 0. Having seen the coordinate axis, we will explore how we use the coordinate axis in locating a point in the coordinate space. Given a point in space, we can measure its distance from the coordinate planes. Let's see how. One way is to drop a perpendicular on the xy plane. Let this perpendicular meet the xy plane at point Q. Then, we drop a perpendicular from Q on the x-axis. This meets at a point, say R. Distance OR is the x-coordinate, RQ is the y-coordinate, and PQ is the z-coordinate. If we are given the coordinates of a point, then we can trace the point as shown. First, we will identify a point, say R, on the x-axis, which is at a distance x from the origin. Next, we draw a perpendicular of length y from point R and parallel to the y-axis on the xy plane to a point, say Q. Lastly, we draw a perpendicular of length z from point Q perpendicular to the xy plane. We can observe an interesting property among the coordinates of the points. Any point that lies on the x-axis will have its coordinates in the form x, 0, 0. For example, a point at a distance of 6 units from the origin on the x-axis will have the coordinates 6, 0, 0. Similarly, the points that lie on y-axis will have coordinates of the form 0, y, 0, and the points on the z-axis will have coordinates of the form 0, 0, z. Here the letters x, y, and z belong to the set of real numbers. Any point on the xy plane will be of the form x, y, 0. Shown here are some points on the xy plane. Any point on the yz plane will be of the form 0, y, z, and a point on the zx plane will be of the form x, 0, z. Here the letters x, y, and z belong to the set of real numbers. Having seen how a given point is traced in space, we will now locate a point using the intersection of planes. First, we will take a plane at a distance x and parallel to the yz plane. Next, a plane parallel to the xz plane and at a distance of y is taken. Finally, another plane parallel to the xy plane and at a distance of z is taken. First, let's take two planes, one parallel to the yz plane and the other parallel to the xz plane. The intersection will be a line parallel to the z-axis. Likewise, the intersection of the other planes creates lines as shown. The concurrence of these lines is point P. The coordinate axes divide the coordinate space into 8 parts, called octants. The sign of the coordinates determine the position of a point in a particular octant. For example, the point 2, -3, 3 lies in the 4th octant. The x-coordinate of the point is 2. So we measure 2 units along the x-axis and mark a point. The y-coordinate is -3. So from this point, we measure 3 units on the xy plane in the direction of OY' parallel to the y-axis. We mark a point there. For the z-coordinate, that is 3, we measure 3 units from the point perpendicular to the xy plane. We can notice that the point lies in the 4th octant.
A few moments later.
These days, we spend a lot of time looking at screens. Computers, smartphones, and televisions are a big part of our lives. They're how we get most of our news, use social media, watch movies, and more. Virtual reality and augmented reality are two technologies changing the way we use screens, creating new and exciting interactive experiences. Virtual reality, also known as VR, uses a headset with a built-in screen that displays a virtual environment for you to explore. These headsets use a technology called head tracking, which allows you to look around the environment by simply moving your head. Augmented reality, or AR, is a bit different. Instead of transporting you to a virtual world, it takes digital images and layers them on the real world around you. This is done through the use of either a clear visor or a smartphone. So with VR, you could explore a world full of dinosaurs. But with AR, you could see those dinosaurs moving through the world around you. Both of these technologies are growing at a rapid pace and being implemented in a variety of different ways. Surgeons are using VR to practice highly technical surgeries before operating. Businesses are using them to give consumers virtual tours of products and locations. There are even apps that can use your smartphone's camera to scan and translate a foreign language in real time. As they continue to grow, VR and AR have the potential to greatly change almost every industry. You'll want to keep an eye on them to see how they might soon affect your job and potentially your everyday life.
Wala kaming pakialam!
A few moments later.
Good morning everyone, I'm Aaron Daniel A. Vitog and here is my report about 3D graphics programming or rendering and comments. So first is the rendering. Rendering is the process of converting 3D models into 2D images that can be displayed on a screen. This involves techniques such as perspective projection,